In the shadowy world of military aviation, few proclamations travel faster than a whisper that the next big leap has already taken off. Russia has set defense circles buzzing with assertions that it is flight testing sixth-generation technologies on the Su-57, its controversial fifth-generation fighter. If these claims are accurate, Moscow may have skipped rungs on the ladder and gained an edge over the United States, China, and Europe. If they are not, the story may be one of the boldest exercises in strategic theater in recent memory. As usual with air power, the reality is likely a turbulent mix of both. A secret that slipped the radar. For years, the Su-57 has been a magnet for debate. Production delays, engine shortfalls, and limited fielding created ample doubt among Western observers. Then, in 2023, Russian state-linked figures began hinting that modified Su-57 prototypes were quietly flying with sixth-generation subsystems on board. Advisors tied to Rostec suggested the upgrades went far beyond software patches, describing a rebuild of the jet's electronic nervous system, its sensors, jammers, and data links, into an integrated architecture meant for tomorrow's battles. Reports spoke of hundreds of test sorties conducted with little fanfare, a campaign designed to generate hard performance data while avoiding the heat of public scrutiny. The implication was clear. While others incubate brand new airframes, Russia is grafting future tech onto a frame it already knows, hoping to accelerate the path from idea to airborne proof. Inside the alleged leap, at the core of Moscow's claims is a triad: electronic warfare, artificial intelligence, and propulsion. The new suite reportedly fuses radar, reconnaissance, and jamming into one system, allowing aircraft to see and disrupt simultaneously while sharing data in real time. AI is said to process sensor feeds, rank threats, and suggest or execute maneuvers in milliseconds, shifting the pilot toward a commander role and enabling control of uncrewed wingmen. Meanwhile, a new engine family promises greater thrust with lower fuel use, supporting longer missions and sustained supersonic flight without constant tanker reliance. If realized in practice, these advances could reshape Russian air power. Racing ahead or reframing the story, the idea of sixth-generation features already flying is exciting but misleading. Even Russian designers admit a true sixth-gen jet is unlikely before the late 2020s, in line with foreign timelines. More likely, Russia is testing individual technologies on existing airframes. That strategy is efficient but blurs the line between experiments and fielded capability, a deliberate ambiguity. By forcing rivals to assume the worst, Moscow gains deterrent value before any squadron is operational. The global race for tomorrow's air dominance. Russia's path fits into a wider race for sixth-generation air power. The U.S. pursues next-generation air dominance, a system of systems where the crewed jet is just one node amid drones, sensors, and networks. Europe is split. The Franco-German-Spanish Future Combat Air System aims for 2040, while Britain, Italy, and Japan push the global combat air program toward the 2030s with strong autonomy goals. China is believed to emphasize Pacific needs, long-range and carrier use. Russia's upgrade the present to test the future approach saves cost and infrastructure, but forces next-gen tech into a fifth-gen frame, accelerating learning while limiting ultimate performance. Smoke, mirrors, and the hard arithmetic of production. Despite its ambitions, the Su-57 program faces stark limits. 14 years after its first flight, production remains modest compared with US and Chinese fleets, squeezed by sanctions, supply issues, and the costs of war. Combat use has been minimal, with the jet largely confined to patrols inside Russia, fueling doubts about stealth, avionics, or readiness. Engines remain a weak link, constraining performance until a new design matures. Export hopes have faltered as India quit co-development and other prospects stalled. These realities undercut the notion that Russia can rapidly turn experimental advances into broad transformation. Between breakthrough and bluff, Russia's progress is neither outright breakthrough nor mere bluff. Su-57 prototypes have flown with real upgrades, testing advanced electronic warfare, sensor fusion, and AI decision aids, all core to future air combat. Yet proving components is far from fielding capabilities. An AI that works in trials may falter in contested conditions. An engine that shines in a lab must endure the grind of squadron life. Beyond technical hurdles lie industrial ones: funding, skilled labor, reliable suppliers, and quality control. Without those, innovations remain prototypes, not power. Why perception still matters. Even partial progress can shape strategy. If NATO must assume Russian jets can jam, network, and team with drones, procurement and training shift toward resilient comms, counter-autonomy, and dispersed ops. War games adjust for faster moves and tougher survivability. The prospect of hypersonic dashes, sharper stealth, and AI-driven tactics broadens the threats blue forces must prepare for. This is deterrence by uncertainty. Moscow need not prove every claim if it can force adversaries to pay against the possibility. Ethics at the edge of autonomy. The specter of a fighter that can find, fix, and finish targets without a human in the loop raises questions that outpace engineering. Western air forces have articulated a preference for meaningful human control, an elastic phrase that tries to reconcile machine speed with moral accountability. Russia's more centralized model may accept risk thresholds that would be politically untenable elsewhere. If Moscow fields semi-autonomous teaming faster, it will force a global conversation about command responsibility, escalation control, and the laws of armed conflict. The technology is racing ahead. Policy must sprint to keep up. The industrial constraint. Air power isn't just software and signatures, it is supply chains, tooling, training pipelines, and sustainment math. To shape a theater, you need aircraft in meaningful numbers, spares on the shelf, and maintainers who can keep jets flying through weather and wear. Here, Russia's constraints bite. Limited production runs cannot deliver mass, and mass is what turns exquisite prototypes into credible deterrence. Even spectacular capabilities, if confined to a handful of tails, have narrow strategic utility. In contrast, programs like the F-35 demonstrate how scale begets learning, cost reduction, and interoperability dividends, advantages that grow each year. For Russia, the question is not merely whether it can integrate sixth-generation tricks onto a Su-57, but whether it can do so for dozens of jets, then hundreds, and keep them ready at squadron tempo. A measured verdict, strip away the hype, and a balanced assessment comes into focus. Russia appears to be pursuing a sensible, if constrained, path. Use an existing platform to trial future-leaning technologies, harvest lessons early, and convert perception into diplomatic and deterrent leverage. That approach can yield real gains in electronic warfare and networking, and it can give Russian pilots decision aids that compress kill chains and complicate enemy planning. Yet the larger proposition that Moscow will field a robust sixth-generation capability years ahead of competitors collides with the realities of industry capacity, budget pressure, and engineering maturity. What emerges is a hybrid picture: significant advances in specific subsystems, meaningful progress toward manned-unmanned teaming, and a public narrative designed to magnify the impact of those steps, while the harder work of engines, stealth, and production grinds forward. What to watch next? The next few years will clarify whether Russia can scale beyond prototypes. Indicators include the pace of Su-57 deliveries, the appearance of a mature clean-sheet engine on operational aircraft, credible demonstrations of loyal wingmen teaming outside scripted trials, and sustained deployments that bring the jet out of the shadows of domestic airspace. On the Western side, the speed at which NGAD, GCAP, and associated drone programs move from concept to hardware will set the competitive tempo. China's progress, particularly at sea, will add a regional wrinkle with global consequences. Meanwhile, counter-autonomy, hardened networks, and distributed operations will become staple investments for any air force expecting to survive in a sky full of sensors and algorithms. The sky of the 2030s? Air combat in the 2030s will not be decided by a single airframe, but by a choreography of crewed fighters, loyal wingmen, satellites, ground sensors, and cyber effects, all stitched together by networks that must function in the teeth of electronic attack. Russia's claim to have flown fragments of that future today is not entirely bluster, but neither is it a coronation. The decisive question is not who flashes the first headline, but who can field, sustain, and evolve an ecosystem of capabilities faster than rivals can counter it. Russia may have earned an early takeoff, and it has certainly earned attention. Whether it can stay at altitude against headwinds of economics and industry is the contest that will define its air power for the decade ahead. And that wraps up our deep dive into Russia's ambitious push towards sixth-generation fighter technology. If you found this breakdown interesting and want to stay ahead of the latest in military tech, aviation, and global defense trends, make sure to hit that like and subscribe to the channel. Thanks for watching, and we'll see you in the next one.